Hi students, today I am going to deal the topic mass spectrometry from the chapter mass spectrometry and chromatography. I am going to deal the topic mass spectrometry from the chapter mass spectrometry and chromatography. Learning objectives. Upon completion of this presentation, you will be able to understand the concepts of mass spectrometry, block diagram of mass spectrometry, components of mass spectrometer, the principle and working of mass spectrometer, advantages and also disadvantages of mass spectrometer, expression for mass to charge ratio, and applications of mass spectrometer. Upon completion of this presentation, you will be able to understand the concepts of mass spectrometry, block diagram of mass spectrometer, components of mass spectrometer, principle and working of mass spectrometer, advantages of mass spectrometer, expression for mass to charge ratio, and application of mass spectrometer. Mass spectrometry. It is an analytical technique or tool that measures the mass to charge ratio of charged particles. Mass spectrometry is an analytical technique that measures the mass to charge ratio of charged particles or ions. It is most generally used to find the composition of physical sample by generating a mass spectrum. It is used to find the composition of physical sample. When you are given a sample, you need to know the composition of that sample by generating a mass spectrum. So what is this mass spectrum? It is nothing but a plot of intensity as a function of mass to charge ratio. It is a plot of intensity to the function of mass to charge ratio. So, it is used to find the composition of physical sample by generating a mass spectrum which represents the masses of sample components. The different masses of the sample components you can identify. You can represent the masses of sample components. These measurements can often be used to calculate the exact molecular weight of the sample components as well. They are used to mass spectrometer. After you are finding the masses of the sample components, the measurements can be used to calculate the exact molecular weight of the sample components. Exact molecular weight of the sample components. Typically, mass spectrometers are used to identify unknown compounds by molecular weight determination, to quantify known compounds and to determine their structure and chemical properties of molecules. So, mass spectrometry is an analytical tool that measures the mass to charge ratio of charged particles or ions. So, this can be used to identify unknown compounds via molecular weight determination, to quantify known compounds and to determine structure and chemical properties of molecules. To determine the structure and chemical properties of the molecules. Block diagram of mass spectrometer. This is the basic block diagram of a mass spectrometer. It consists of 3 blocks. One is the ion source, then your mass analyzer and the detector. The sample is given to the ion source and the output of the ion source is given to the mass analyzer. From the mass analyzer, it is given to the detector, and we analyze the data that is being sensed by the detector. So, data analysis. So, the block diagram consists of 5 blocks: sample, ion source, mass analyzer, detector and data analysis. Mass spectrometer mainly consists of three parts as we have seen in the block diagram earlier in the previous slide. It consists of three main parts, that is an ion source, a mass analyzer and a detector system. Sample is given to the ion source and the output of the detector system is used for analysis, for data analysis. So the three basic components of any mass spectrometry are the ion source, the mass analyzer and the detector system. Coming to the brief discussion about the components of the mass spectrometer. The first, as I told you, we have three components: ionization source, then your mass analyzer, and the third one is the detector system. So let us discuss the first component of the mass spectrometer, that is ionization source. Molecules are converted into gas phase ions so that they can be moved about and manipulated by external electric and magnetic fields. So the sample molecules, they are converted to, if they are in the liquid phase, they are converted to gas phase, so that the gas phase ions, so that they can be moved about and manipulated by external electric and magnetic fields. They can be moved and manipulated by external electric and magnetic fields. A technique called nano electrospray ionization, which is somewhat similar to how the cars are industrially painted, is used in this ionization source. You are using a technique called nano electrospray ionization technique, which is most commonly used in industrially painted cars. Okay, this method allows for creating positively or negatively charged ions. During the process of ionization, what happens? Positive and negative charged ions are being developed depending upon the experimental requirements. Nano electrospray ionization can directly couple the outlet of the small scale chromatographic column directly to the inlet of a mass spectrometer. So when this ionization, that means where the sample is being converted into a gaseous phase ion, it can be directly connected, the chromatographic column can be directly connected to the inlet of the mass spectrometer. The flow from the column is passed through a needle that is about 10 to 15 micrometers at its tip. There is a needle which is used to deliver the gaseous phase ions into the mass spectrometer. So ionization source, molecules are converted to gas phase ions so that they can be moved about and manipulated by external electric and magnetic fields. A technique called nano electrospray ionization technique is used, which can be directly coupled to the outlet of a small scale chromatographic column directly to the inlet of a mass spectrometer. The second component of the mass spectrometer is mass analyzer. After the sample is ionized and now the sample is in the gaseous state and it is ionic in nature, once the sample is ionized, the ions are sorted and separated according to mass to charge ratio. So there are a number of mass analyzers currently available, each of which has a trade-off relating to speed of operation, resolution of separation and other operational requirements. What happens in the mass analyzer? The ionized sample particles that are ionized are sorted and separated according to a In this mass analyzer, what is happening? They are sorted and separated according to the mass to charge ratio. Mass to charge ratio. And depending upon the mass analyzer that are available, we have they have their own speed of operation and the resolution of separation and other operational requirements are there for each type of mass analyzer depending upon the nature of the sample which we are analyzing. Coming to the third component, ion detection system. Now the ions are separated. First phase, the sample is converted into gaseous state. Ionization is taking place there. After the ions are being produced, they are being separated using the mass analyzer based on the mass to charge ratio. After they are separate, they need to be detected how many ions are present. So the separated ions are then measured and sent to a data system where the M by Z ratios are stored together along with the relative abundance. Where the M by Z ratios are stored together along with their relative abundance. The separated ions are then measured and they are sent to the data system where the M by Z ratios are stored together along with their relative abundance. A mass spectrum is simply the M by Z ratio of the ions present in a sample plotted against their intensities. So, a mass spectrum, you get a spectrum for that. It is nothing but, as I told you earlier, what is the mass spectrum? The mass spectrum is the it is nothing but excuse me, a plot of the intensity of the function of the mass to charge ratio. A plot of the intensity as a function of mass to charge ratio. That is called the mass spectrum. Intensity versus mass to charge ratio. So, in the third component, in the ionization detection system, the separated ions are then measured and they are sent to a data system where the M by Z ratios are stored together along with their relative abundance. The abundance means how much they are present, how many ions are present. So, a mass spectrum is simply the M by Z ratio of the ions present in a sample plotted against their intensities. So, each peak in a mass spectrum shows a component of unique M by Z in the sample. We will be getting several peaks. So, each peak will represent a specific component of the sample, and the height of the peak connotes the relative abundance of the various components in the sample. Okay, the height represents the abundance of the components in the sample. Abundance means how much they are. Okay, each are represented by a peak. You will be getting a waveform with relative abundance on taken versus M by Z ratio in the sample. So, this is how the mass spectrum appears. This is how the mass spectrum appears. This is a graph where you are taking M by Z ratio on the x-axis and relative abundance on the y-axis. So, you are getting several peaks. So many components are there in that given sample. This is an example. It is an example. So, the height of the peak represents the abundance. How many are present? How many ions of a specific mass are present? How many ions of a specific mass are present? So, this is your mass spectrum which represents, which is drawn by taking M by Z ratio on the x-axis and relative abundance on the y-axis. Each component will have its own peak. And the height of the peak is represented by the abundance of the sample. The height of the peak is represented by the abundance of the sample. Okay. Then coming to the different stages in mass spectrometry. I will like to go into the depth of this mass spectrometry. So I have told you now we have three components. The first component is ion source, second component is your mass analyzer, and the third component is your ion detection system. First is your ion source, mass analyzer, and then your ion detection system. So in this mass spectrometry, it is carried out in different stages. It is carried out in different stages. The first stage is production of ions from the sample. The production of ions from the sample. Second one, separation of ions with different masses. You are going to separate the ions with different masses. That is the second step. Second stage it is called. Third one, detection of number of ions of each mass produced. Detection of number of ions of each mass produced. These are the basic stages, different stages in mass spectrometry. Collection of data to generate the mass spectrum. Collection of data to generate the mass spectrum. So, the different stages in the mass spectrometry are production of ions from the sample, separation of ions with different masses, detection of number of ions of each mass that are produced, and collection of data to generate the mass spectrum. Collection of data to generate the mass spectrum. Separation of ions with different masses, detection of number of ions of each mass produced, and collection of data to generate the mass spectrum. Collection of data to generate the mass spectrum. So this is your basic diagram of a mass spectrometer. Basic diagram of a mass spectrometer. Schematic diagram of a mass spectrometer. The first stage is your ionization stage. The first stage is your ionization. You can see in the figure, the first stage is the ionization stage, where you have an ion source. Ion source is there. Okay, I am going to discuss in detail about this ionization source, ionization process. The second one is your acceleration of the electron beam in a uniform magnetic field. What happens? How do you accelerate the electron beam? Then the third phase is your deflection phase, and the fourth phase is your detection phase. So we have 4 stages: ionization phase, acceleration of the ionized sample, then deflection phase, and then detection phase. So coming to the first phase, ionization and fragmentation phase. Ionization and fragmentation. Electroionization, as I told you earlier, you are going to use electroionization. It is the most common type of ionization. The sample is bombarded with electrons. Okay, your sample is being bombarded with electrons. The sample in the is a vaporized sample. When it is passed through an electrically heated, the sample is bombarded with electrons which come from a heated filament. So you have a heated filament, electrically heated filament. The filament will be emitting electrons. The electrons will run in a stream between the cathode and the anode. We have the cathode and an anode. So the electrons will be electrically heated metal coil is there. Okay, filament or coil. The electrons run in a stream between the cathode and the anode. Between the cathode and the anode. When the sample passes through the electron stream, okay, your element is heated element is filament is emitting electrons. Okay, when this heated filament is emitting electrons in the form of a beam, the electrons run in a stream between the cathode and the anode. So the sample is passed through the electron stream. So the high energy electrons in the stream knocks electrons out of the sample to form ions. So these high energy electrons, what do? They knock the samples to form ions. They knock out electrons of the sample to form ions. In the simplest case, ionization is nothing but removal of electron to give an atom with an overall positive charge. Okay. So you are having the vaporized sample, the sample in the gaseous state. Now what you are doing? You are allowing the sample to pass through an electron beam. So this electron beam bombards the sample. When it bombards the sample, the energy it takes from the bombarding sample, when it passes through the electron stream, the high energy electrons in the stream are knocked down and the sample is going to change into ionic form. So it is the simplest case, that is, you are removing the electron from the outermost orbital of an atom and making it positive charge. So overall it is, you are changing the charge of the ions, charge of the atoms. When you are knocking, the sample is being bombarded by high flowing electrons, high energy electrons. The electrons in the outermost orbit of the atom are removed. When they are removed, that atom will become positive ion. It will become positive ion. So this is also called as fragmentation. Okay, this is taking place, ionization and fragmentation. Ionization and fragmentation. Then, as I told you earlier, after the ions are formed, they must move to the next stage. How can they be moved to the next stage? By the acceleration. Acceleration is a simple step where the ions are placed between a set of charged parallel plates. When the ions are allowed to pass through charged parallel plates, the ions will then be repelled by one plate and attracted to the other. When the plates are charged, and they will be repelled by one plate and they are attracted to the other plate. Okay. There is a slit cut in the plate which the ions are attracted to. The force of attraction and repulsion forces the ions through the slit at an accelerated rate. So as you can see in the figure, you have plates. Intermediate plate is there, then final plate, and then you have, this is an ionization chamber, which is an ion beam is passed into this chamber. The ionization chamber is maintained at very high potential of 10,000 volts. So now what is happening? Because of this high potential, the ion beam will be accelerated. It will be accelerated. The speed of acceleration can be adjusted by changing the charge on the plates. When you change the charge on the plates, the speed of the acceleration can also be adjusted. Okay. The final plate is at 0 volts. The ionization chamber is maintained at 10,000 volts. The ion beam is allowed to pass through the slit which is cut in the plate. Okay, the force of attraction and repulsion forces the ions through the slit at an accelerated rate. Through the slit they enter at an accelerated rate. So this is the acceleration phase or acceleration part of the mass spectrometer. Then after the ion beam is accelerated by maintaining high potential between parallel plates, now the ion beam is moving very fast. It is accelerated. So after acceleration, what you have to do, the next phase is deflection. Ions are deflected by the magnetic field surrounding the instrument. So the amount of deflection depends upon the mass to charge ratio. The amount of deflection depends on the mass to charge ratio of the ion. The heavier ions and ions with positive charge of 2 or more are deflected. The heavier ions, we have ion stream A, ion stream B and ion stream C. The heavier ions and ions with positive charge of 2 or more are deflected the least because they are heavier, so their deflection is very less. So the ion stream is deflection of the ions which are heavier. The lightest ions and the ions with one positive charge are deflected the most. That is the ion stream A. They are more deflected. The ions which are lighter and ions with one positive charge are deflected most. Ions with correct mass and charge travel to the detector. Ions at the correct mass and they travel straight almost onto the detector. Ions that are at correct mass and charge travel to the detector. That is ion stream B, which is ion stream B. So this is your deflection system, which consists of a magnet, and your ion stream is allowed to flow. Electromagnet is used, and the ion stream, when it is allowed to pass through this electromagnet, based upon the charge to mass ratio, if the ions are heavier, they move towards they follow the pattern ion stream C, and they move, if they are heavier, they move towards the ion stream C, and if they are lighter, they move towards ion stream A. And if the ions at the correct mass and charge travel to the detector, that is ion stream B, they travel to the detector. So what is the detection system? When the ion stream reached the detector, they hit a wire. When the ion stream, that is ion stream B will reach the detector. When the ion stream B reaches the detector, they hit a wire. On hitting the wire, they become neutralized by an electron jumping from the metal wire to the ion. So the amplifier picks up this current being created between the wire and the ion and amplifies the signal being detected. So the ion beam which is reaching the detector, it strikes a wire. On hitting the wire, they get neutralized by by an electron jumping from the metal wire to the ion. The amplifier picks up the current being created between the wire and the ion. A current will be generated between the ion and the wire, and this can be amplifies and it can be amplified and it can be detected. So the computer picks up this current and converts it into a mass to charge ratio, and a spectrum is produced, and it is get converted into a mass to charge ratio, and a spectrum is produced. So in the detection system, the ion stream, it reaches a detector, they hit a wire. On hitting the wire, they become neutralized by an electron jumping from the metal wire to the ion. The amplifier picks up on this current being created between the wire and the ion and amplifies the signal being detected. The computer picks up on this and converts it to mass to charge ratio, and a spectrum is produced. Coming to the principle. So the sample to be analyzed is first bombarded with an electron beam to produce ionic fragments of the original molecule. Okay. The principle of operation of this mass spectrometer is, the sample which is to be analyzed is first bombarded with an electron beam to produce ionic fragments of the original molecule. These ions accelerated by passing through them an electric field. They are accelerated by passing through them an electric field. Then they are sorted by according to their mass to charge ratio by passing them through magnetic field. Okay, both electric and magnetic field. Electric field is used to accelerate the ions. Magnetic field is used for deflection. to deflect the ion beam. A record of number of different kinds of ions is called mass spectra. So each ion has its own characteristic, each type of ion. Okay, depending upon the different kinds of ions, you get a mass spectra. By varying accelerating voltage, ions from other mass species may be calculated. Ion currents measured in such cases would be proportional to the amount of a given mass species present. By counting the number of the ionic current begins to flow, so that is proportional to the amount of given mass species present. Amount of given mass species that are present. Procedure and operation. The procedure and operation that is followed in a mass spectrometer are: the substances are converted first into the sample is converted into gaseous state by chemical means. Then it is introduced into a highly evacuated spectrometer tube, where the sample is ionized by means of an electronic beam. The positive ions are deflected and focused by means of a suitable magnetic and electric fields. For a given accelerating voltage, area positive ions of specific mass pass through the slit. They reach the collector plate. The ion current produced are amplified and measured using an electrometer tube. So first the sample is being converted into a gaseous state by means of chemical means. Then it is introduced into a highly evacuated spectrometer tube. It is ionized by means of an electronic beam. The positive ions are deflected and focused by means of a suitable magnetic and electric fields. For a given accelerating voltage area, positive ions of specific mass pass through a slit. They reach the collector plate. The ion current produced are amplified and measured using a electrometer tube. So this is the working principle of a mass spectrometer. Working principle of a mass spectrometer. A position, use your ion source. So the ion source will produce the ions, and B is the location, that is the slit through which the ions produced, they are accelerated. Okay. B is the ions. C is the magnetic field around the ions that are generated are accelerated in vacuum into a magnetic field C. Then this magnetic field, what does it do? It deflects the ion beam in a circular path. The deflection of light ions is greater than that of the heavier ions. So the lower curve is for heavier ions and the upper curve is for light ions. Light ions, as they are lighter, they can be deflected at a greater distance. The accelerating voltage and the ion stream separate into, so as I have told you earlier, ion beam A, B and C. So A is for higher, heavier, lighter beam, ion beam. So they are deflected more, and heavier ion beams, they are deflected less. Where the charge to mass ratio is equal, they go and fall on the collector electrode, which is E. So the accelerating voltage on the ion source is gradually reduced. When the acceleration voltage is gradually changed, it can be changed by changing the acceleration voltage. What happens? You can identify the mass of the species. Can be by varying ions for other mass species may be collected. When you change the acceleration voltage, you can find the other mass species also can be collected at the electrode. So the working of mass spectrometer, as I shown you in the figure, molecules in the gas sample A A, B, C, D I have represented in the figure. You can see the previous slide. Molecules in the gas sample A to be analyzed are bombarded. They are bombarded with electrons. So they produce ions. B represents the ions. Now these ions are accelerated in vacuum in a magnetic field C. C is the magnetic field. When they are accelerated in vacuum in a magnetic field, they get deflected. If they deflect, it deflects them into a circular path D. The deflection of the light ions is greater than that of the heavy ions. The deflection of the light ions is greater than that of the heavy ions. The ion stream separated into beams of different molecular weight to pass through to a collector electrode E. So the accelerating voltage on the ion source is gradually reduced. The acceleration voltage on the ion source is gradually reduced. It is gradually reduced. Advantages of mass spectrometer. The advantages of mass spectrometer are, they are small, the very small size of the sample is required for analysis, and they are fast scanning. They can differentiate isotopes. They can be combined with GC and LC. GC stands for gas chromatography and LC for liquid chromatography, which I will be discussing in the forthcoming classes. So they can be combined with GC and LC to run the mixtures, can be used for insoluble samples, can be used for analysis of high mass compounds. They can handle high flow rate compounds. Accuracy is high accuracy they have, and they are inexpensive. These are the advantages of mass spectrometer. Small size of the sample is sufficient. They are fast in scanning. They can differentiate isotopes. They can be combined with gas chromatography and liquid chromatography to run mixtures. They can be used for insoluble samples. They can be used for high mass compounds. They can handle high flow rates. They have high accuracy, and they are less expensive or inexpensive they are. Then what are the disadvantages of mass spectrometer? Mass spectrometer doesn't directly give structural information. It doesn't directly give the structural information of the component of the species that is being detected. It needs pure compounds. Difficulty arises with non-volatile compounds. Usually the compounds must be volatile in nature, but here you face a difficulty if the compounds are non-volatile, that which does not vaporize. Non-volatile means which vaporize easily. Non-volatile which does not vaporize. So that is the disadvantage. You cannot directly get the structural information. The compounds that are being analyzed must be pure, and it is difficult to analyze with non-volatile compounds. Then coming to the next topic is derivation. The derivation for mass to charge ratio, M/E ratio. This is very, very important. As we have seen in the ionization, ion source, the ions are generated. How the ions are generated? When the sample is vaporized, it is changed into gaseous state. When an electron beam is bombarded on the sample ions, the sample atoms are converted into electrons. Are converted into ions. They are converted into ions. So now the sample is in ionic state. So it is passing through the accelerating electric field. So what happens? When ions pass through an accelerating electric field, they have kinetic energy. So half mv square is the kinetic energy of the ion. And it is equal to EV. So half mv square is equal to EV. where m is the mass of the ion, E is the charge of the ion, V is the velocity of the ion, and capital V is the accelerating voltage. Capital V is the accelerating voltage. So EV, that means because of the kinetic energy, because of the accelerating electric field, the ions are able to move faster. There is an increase in their kinetic energy. So energy is neither created nor destroyed based on that relation. How much energy is applied because of the accelerating electric field? The energy is EV. V is the accelerating voltage. That is equal to half mv square, where m is the mass of the ion which is being detected, E is the charge of the ions, and V is the, small v is the velocity of the ion, and capital V is the accelerating voltage. So half mv square is the kinetic energy of the ions leaving the electric field. So this is equation 1. This equation 1 can be rewritten as, if you find the value of small v, that is the velocity of the ion, V is equal to, from the relation, relation 1 can be simplified as V is equal to square root of 2 EV by m. It is square root of 2 EV by m. So now V is equal to, V is what? Velocity. Small v is the velocity of the ion. It is represented by the equation 2. So when this ion enters into the magnetic field, which is at right angle to the direction of motion, the ion would be diverted into a circular orbit. So when the ions enter into magnetic field, which is at right angles to the direction of the motion, the ions would be diverted into circular orbits. The ions will be diverted into circular orbits. So the equation equating centripetal and centrifugal forces, now it is rotating. The ion is moving in the circular path. So you have what type of force? Centripetal force. So mv square by r is equal to HEV. So the relation equating centripetal and centrifugal forces, mv square by r is equal to H into EV, where H is the magnetic field intensity, R is the radius of curvature. Earlier you already know mv square. M is the mass of the ion, V is the velocity of the ion, R is the radius of curvature, H is the magnetic field. So the equation 3 now becomes as R is equal to, from the equation 3 we will be finding the value of R. R is equal to mv by EH, m small v by EH. R is equal to m small v by EH. So substituting equation 1 in equation 4, you will be getting, substituting equation 1, substituting the value of V in equation 1, value of E in equation 4, we get R is equal to square root of 2 EV by m into m by EH. 2 EV by m into m by EH. So this is equation 5. So by simplifying the above equation, we will get the equation. Now you want to find the mass to charge ratio. Mass is m, charge is E. So from the equation 5, you can simplify the equation and get the relation m by E is equal to h square r square by 2v, 2 capital V. Remember, it is capital V. M by E is equal to h square r square by 2v, where h is what? Magnetic field intensity, r is the radius of curvature, capital V is the voltage, accelerating voltage. Okay, all these H, R, V all are known. So except M and V, all parameters are constant. By varying V, it is possible to cause an ion of any mass to follow the path which may coincide with an arc of an analyzer tube in the magnetic field. So M by E ratio is given by H square R square by 2V. where H is the magnetic field intensity, R is the radius of curvature, and capital V is the accelerating voltage. So this is the expression for mass to charge ratio. Mass to charge ratio is equal to H square R square by 2 capital V, where H is the magnetic field intensity, R is the radius of curvature, and capital V is the accelerating voltage. So, the applications of mass spectrometer. Mass spectrometer has various widespread applications in various fields for analysis of pharmaceutical analysis, bioavailability studies. It is used in pharmaceutical analysis, drug metabolism studies, and pharmacokinetics. Then characterization of potential drugs, drug degradation, product analysis, identifying drug targets. So it is used in pharmaceutical analysis. Then biomolecular characterization, that is to characterize proteins and peptides. Then oligonucleotides, that is called, are short DNA or RNA molecules that have a wide range of applications in genetic testing, research, and forensic. So they are used for biomolecule characterization, proteins and peptides, and oligonucleotides. Then environmental analysis also, pesticides on foods, it can be analyzed to find the pesticides on foods, and soil and groundwater contamination. Environmental analysis, soil and groundwater contamination. Also it is useful for analysis of soil and groundwater contamination. So these are the application areas of mass spectrometer. So, to summarize our topic of discussion today, on completion of this presentation, you have understood the concepts of mass spectrometry. Mass spectrometer is, you have understood the concepts of mass spectrometer. What is a mass spectrometer? Mass spectrometer is an analytical tool or technique that measures the mass to charge ratio of charged particles or ions. It is a tool or technique that is used to measure the mass to charge ratio of charged particles or ions. Mass spectrometer is used to identify unknown compounds via molecular weight determination, and to quantify known compounds, and to determine structures and chemical properties of the molecules. Then we have studied about the block diagram of mass spectrometer. It consists of basically 3 blocks. Totally 5 blocks are there. The sample is given to the ion source. Then you have from the ion source it is given to your mass analyzer, then to the detector, and for analysis you have data analysis. The components, the 3 basic components of a mass spectrometer are, mass spectrometers are mainly consists of 3 components: the ion source, mass analyzer, and detection system. The ionization source, the molecules are converted to gas phase ions so that they can be moved and manipulated by external electric and magnetic fields. So a technique called nano electrospray ionization technique is used, which is used to produce positively or negatively charged ions depending upon the experimental requirement. Then your mass analyzer, once the ions are formed, once the sample is ionized, the ions are sorted and separated according to their mass to charge ratio in the mass analyzer. Then your detector system, the separated ions are then measured and sent to a data system where the M by Z ratios are stored together along with their relative abundance. So mass spectrum is simply the M by Z ratio of the ions present in a sample plotted against their intensities. So the different stages in mass spectrometer is ionization stage, where production of ions from the sample is formed. Then the second stage is your acceleration stage, where the ion beam is accelerated between two parallel plates which are maintained at high potential, and the plates, you have a slit between them, so the ion beam passes through the slit. Then the third phase is your deflection phase. Deflection phase, where the accelerated ray of light is accelerated beam. The ions are being deflected by magnetic field surrounding the instrument. The amount of deflection depends upon the mass to charge ratio of the ions. The heavier ions will deflect less, whereas the lighter ions will deflect more. So the ions at the correct mass and charge will travel to the detector. Then your detector system, when the ion streams reaches the detector, they hit a wire. On hitting the wire, they become neutralized by the electrons jumping from the metal ion wire to the ion. The amplifier picks up this current being created between the wire and the ion and amplifies that signal that is being detected. The computer picks up this signal and converts it into mass to charge ratio, and a spectrum is produced. So the principle is, the sample to be analyzed is first bombarded with electron beam to produce ionic fragments of the original molecules. These ions are accelerated by passing them through the electric field. They are sorted out according to their mass to charge ratio by passing them through magnetic fields. A record of number of different kinds of ions is called as mass spectrum. By varying the acceleration voltages, ions from other mass species may be collected. The ion currents measured in such cases would be proportional to the amount of given mass species. So the advantages with this mass spectrometer are, they are small in size, small size of samples are sufficient enough, fast scanning, they can differentiate isotopes, they can be combined with gas and liquid chromatography to run the mixtures. They can be used for insoluble samples, they can be used for high mass compounds, they can handle high flow rates, they have very high accuracy, and they are less expensive. The disadvantages are, they cannot directly give the structural information, pure compounds are needed, and there is a difficulty with non-volatile compounds. The mass to charge ratio is given by the relation h square r square by 2v, where h is the magnetic field intensity, r is the radius of curvature, and v is the accelerating voltage. And finally, the applications of mass spectrometer are, they are used in pharmaceutical analysis for characterization of potential drugs, drug degradation, product analysis, identifying of drug targets, and in biomedical characterizations like proteins and peptides and oligonucleotides. Then in environmental analysis for pesticides on foods, soil and ground contamination. So these are the applications of mass spectrometer. So with this, I would like to end my presentation on mass spectrometer.